Unit 8, Day 2 notes. Today we'll talk about simplifying radicals some more and the Pythagorean theorem. So now we're going to simplify radicals that aren't perfect squares. Very similar to what we did on the previous lesson. You're going to break apart the number into its factors. So what I would do is pull the number to the side and develop a factor tree. So I know what two numbers would form 18. 9 and 2, right? And then 9 can be broken down into further factors of 3 and 3. If I can't break the number into its prime factors any lower than this, then come back to the square root sign and list all the factors out. So essentially we're going to have 3 times 3 times 2 make 18. If you want to double check, 3 times 3 is 9. 9 times 2 is 18. And then again, the same rule applies that whenever you see a pair of numbers, go ahead and circle them, and then cancel one out, and one will come outside the sign. Whatever doesn't come outside the sign will stay in the sign. So we had a 3 come outside, 1 3 was canceled out, and then a 2 will remain in the sign. So 3 square root of 2 would be the final answer to simplifying the square root of 18. I'll let you do number 2 for yourself, as well as number 3. Jump down to number 4. So 72 is the only thing under the square root sign. So let's factor 72. So I know 2 goes into 72, but I also know that it would be 36. 2 and 36. So now I would have to break apart 36 into its factors. I know that 36 is 6 times 6. So I'm going to bring down the 5 outside, and then inside the square root, I'm going to list the 6 times 6 times 2, because that was 72. And again, I see a pair of 6's. So I'm going to circle the pair, cancel one out, and one will come outside to join the 5. Anything that comes outside will multiply with whatever is already existing out there. So it'd be 5 times 6, which is 30, outside the sign, but the 2 will stay inside the sign. So it's 30 square root of 2. Ooh, that was a horrible circling job. Alrighty, there's several questions for this picture, and let's go through each one. First question, what is the side length of square A? So just count, and it's 3 units. The side length of square B, I see 4 squares, so that's 4 units. And the side length of square C is 5 units. The area of square A. If you don't remember, the area formula for a square is side squared. In other words, side times side. So for A, it would be 3 times 3, which is 9. For square B, the area would be 4 times 4, which is 16. And for C, the area would be 5 times 5, which is 25. Or technically, you could have counted all of the squares that you see within the entire square. The next question says, what is the sum of the areas of square A and square B? So the sum of A and B areas would be 9 plus 16, which is equal to 25. And then it asks what shape is formed by the three squares. Well, you see a triangle. Oops. And specifically a right triangle. And now we're going to get into the Pythagorean theorem. You should have discussed the Pythagorean theorem back in junior high or intermediate school. But if you've forgotten, the Pythagorean theorem is a squared plus b squared equals c squared. We're going to use the Pythagorean theorem to solve for x in number 5 and 6. The first thing to do is always label c. C is always located across from the right angle. And then after you label C, label A and B. And when you label A and B, it truthfully does not matter which is which. And then if I were you, I would write down the theorem, A squared plus B squared equals C squared. And then substitute. So that means I would have my parentheses just ready to go. So A is 9, B is 12, and C is x. And now carry out the squares. So 9 squared is 9 times 9, which is 81. 12 squared is 12 times 12, which is 144. And x squared is simply just x squared. Now add 81 and 144. I believe it is 125 or 225. And then to solve for x, again, we got to take the square root of both sides. So x is equal to the square root of 225. Grab our calculator. Square root of 225, I believe, is 15. So x equals 15. All right, let's go to number 6. Again, first things first, label C, which is always across from the right angle. And then label your A and your B. Write down the theorem, A squared plus B squared equals C squared. And then get ready to substitute. So A is 15, B is x, and C is 39. 15 squared is 225, as we figured out from the previous problem. X squared is simply x squared. And 39 squared, let's grab the calculator for that one, that's large. And if you want to square something, you simply just hit x squared, and it'll attach the power of 2 to it. So 1521. Now, notice it's 225 plus x squared. So to get x squared by itself, I would have to subtract 225 from both sides of the equation. So let's get our calculator for that again. So 1521 minus 225. Excuse me, is 1296. So we have x squared equal to 1296. And then we have to take the square root to get x by itself because we're not done yet. So x is going to equal 36. Complete 7 and 8 on your own and take a picture. There's something out there called the common Pythagorean triples or Pythagorean triples. And you see below a list of some common ones that are used quite frequently. So should you see two of the three, you should understand the third one that would come up. So if you can memorize these common ones and recognize them anytime you see them, it could definitely save you some time. You won't have to go through the entire Pythagorean process if you can memorize this list. Number 9 says, could the following sides form a triangle? A right triangle, specifically. So this is a little different than what we've done in the past. To form a right triangle, we have to prove Pythagorean's theorem. So we have to prove that a squared plus b squared is equal to c squared. C is always across from the right angle, meaning it's always going to be the longer side. So our job is to prove that this is A, this is B, and this is C, essentially. So let's take care of that right now. So let's substitute in. So we would have 14 squared plus 48 squared should equal 50 squared. So 14 squared plus, what was it, 28? 48. 48 squared is 2,500. And 50 squared is also 2,500. So both sides equal, which is a good thing. So we would have 2,500 equal to 2,500. So yes, this is a right triangle. Do number 10 on your own. Now we're about to get into word problems, and what you see right now are some helpful hints on how you would develop your picture from the word problems that you read if one is not provided. So if you see some of these keywords or key phrases, use them to help. It'll be very helpful, trust me. Number 11 provides us a diagram, which is nice, and we're going to use it for these questions. First question is solve for x. So if you look at it, it's a rectangle but split into two right triangles. So I can use Pythagorean's theorem to find x. C is 34. We're going to call A x, and b 30. So that would be, again, a squared plus b squared equals c squared. In other words, x squared plus 30 squared should equal 34 squared. So x squared plus 30 squared, I believe, is 900. But 34 squared, I'm going to need my handy dandy calculator for. $11.56. So to get x squared by itself, I would have to subtract 900. So let's do that first. When I subtract 900, I should have 256. And now I have to take the square root of that. Well, square root of both sides. So x is going to equal the square root of 256 which is 16. And if you want, you can add it to the picture. B wants to know the perimeter of the triangle. So perimeter means add up all the sides. So that's 16 plus 30 plus 34. 16 plus 34 is going to give me 50. So 80 in total. What is the area of the rectangle? Area of a rectangle, if you forgot, is length times width. So the length of the rectangle is 30. The width is 16. 16 times 30. Well, 16 times 3 is 48. So add a 0. So 480. D, imagine if Jasmine walked around the park to get from A to C. So it's not labeled, unfortunately. This is A. This is C. On her way home, she cut across diagonally. How much shorter was her return trip? So to go from A to C, so originally she went down 16 and right 30. So 16 plus 30 was her original distance, and that was 46. But when she cut across from C to A, she only went a distance of 34. So 46 minus 34 is going to give me 12. So it was 12 units shorter to cut across. Number 12 says a 15-foot telephone pole is supported by a wire. The wire touches the ground 8 feet away from the base of the pole. So we have a pole that's 15 feet with a wire hanging from it to the ground. It's a long wire, sorry. So here's my right angle. And it says the wire touches the ground 8 feet away. Sorry, it's not drawing a scale, obviously. And then it says, what is the length of the wire? So the length of the wire will be the hypotenuse, which is across from the right angle. So let's call that x. And now that I've drawn the picture, you can finish the problem on your own. Number 13. During a storm, a tree breaks 6 feet off the ground. the top of the tree falls and touches the ground 8 feet from the trunk. So we had a tree that decided to break and fall. So it broke right about here, 6 feet up. And then it hit the ground. So it's laying down here on the ground. And this length of where it touches the ground is 8 feet from the bottom. It says, what is the original height of the tree? So first, you're going to have to find this part of the triangle. So this is x, the hypotenuse. So let's go ahead and take care of that right now. So we know it would be a squared plus b squared equals c squared. So we're looking for c. So 6 squared plus 8 squared equals c squared. 6 is 36. 6 squared is 36, sorry. 8 squared is 64. 36 plus 64 is 100. And then you take the square root. So 10 is equal to c. So 10 is the broken part. But we want the original height of the tree. So when you take the broken piece plus the 6 feet to get the original height, so 10 plus 6 or 16 feet is the original height of the tree. This concludes your notes for the day. Any questions I've missed, you're welcome to try on your own to see if you did them right.